Hi, I'm Jeff Brubaker, Marketing Manager at G2 Building Products, and I'm thrilled to be hosting this online call with experts on MST structural fiberglass rebar, structural engineering, and, of course, insulated concrete forms. We're calling this panel discussion Your Top 10 MST Bar Questions Answered. Now, to be fair, we actually have a couple bonus questions, so it's more like the top 12. Anyway, why are we doing this? Well, G2 Building Products has partnered with MST Rebar Inc. to provide MST Bar fiberglass rebar to the ICF industry across United States and Canada. As the construction industry is changing and fiberglass rebar is quickly becoming the preferred method of reinforcement, it's important to clarify what exactly MST bar is and how it compares to other fiberglass bar in the market, but also how does MST bar compare to the conventional steel rebar, and why are contractors quickly switching over? Well, as you know, Matt, the questions our panel is going to address today come from comments made on your previous videos about MST bar. And so now today, we've got something even extra special. We've compiled a team of experts to answer the questions that your YouTube viewers have asked and want to know about. First, I want to introduce Borna Haji Marala. And Borna is the founder and CEO of MST Rebar Inc. Thanks for joining us, Borna. Next, we have Alicia Aikenberry. And Alicia is a professional structural engineer who is based in Idaho. And Alicia has 20 years of experience in structural design engineering, project management, field review, and construction administration. Alicia, thanks for being on this call. And Marty, as some of you may have met before as well, Marty is the MST Bar technical advisor here at G2 Building Products. And Marty has been involved in the ICF industry for over 30 years. Marty is one of the few go-to experts for installer training and solving problems that others just can't seem to figure out when it comes to ICF. So Marty, thanks again for being on this call as well. And of course, Mr. NYA Millennial Matt Parr. Okay, so let's jump in. First question that we want to ask here is this one is going to be directed towards Borna. And Borna, this is a question from NYA Millennials channel, but what is MST bar made with? And more in context, from a materials used point of view, how can we be assured of its structural integrity?
Thanks, Jeff. That's a really good question. MST bar is manufactured by glass fiber. Glass fiber are a tiny fibers that are about 1/10, 1/3, 1/4 of your hair diameters, and they are getting impregnated into a very high performance polymer. This is, in our case, is a vinyl ester resin. Vinyl ester resin is a very, very high resistant to corrosion, very strong, high temperature resistant. And those glass fibers are in the form of strands are causing the bar to have that tensile strength, and obviously shear performances and all the other performances that we see. So the material is manufactured by glass and fibers put together to create a composite rebar.
Great. Any other comments from like Alicia? I know you've had a lot of experience with this. You said non-metallic rebar is really how you got involved in this. How have you been able to use that in your drawings and in your designs?
Well, my master's thesis was on composites, so I actually did a lot of hands-on building of composites using glass and carbon and all that type of stuff. In grad school we made our own skateboards, so understanding the resin, how the resin's so important with the glass fiber and cure. And I think a lot of it is finding the best product that does the best of all of it. So it's like a recipe. So the best recipe is going to always be the best. So, you can have chocolate brownies from somebody. They're still chocolate brownies, but they're not as good as the ones that your grandma made, kind of thing. And that's what rebar, glass fiber rebar is. It's all about the recipe and how you cook it and bake it, and the end product is a reflection of that.
And I guess that's where MST Bar really stands out, is the recipe and the formula of MST Bar is what makes that grade 3 structural bar really possible.
Yes, comparing it across the board, it is amazing. My preference.
Just
Love it.
I would love to add one more comment. I think Alicia really pointed out well. Glass fiber and resin is not a new materials. If you go back to the history, glass fiber and rebar has been in glass fiber and resin has been in the market for 80 years. This industry has been fighting corrosion. Boats, fiberglass yachts, fiberglass pipes, underground tanks. These materials has been out there for 80 years, outperforming steel in every case. Some of these tanks are in locations that the steel tanks cannot stay there more than 6 months. And you got a fiberglass tank sitting there for 30 years. What's really made MST Bar unique is a process. So the glass is the same glass. Yes, there has been a lot of improvement in the quality. Resin is the same resin, and it's a new generation of the resin, but it's the process that makes the difference. As Alicia mentioned, it's the cooking recipe, the temperatures, your mixtures, and the combination of the sizings and so on that would makes this different.
Here's another question, and this one's kind of a more detailed question about the bar and its use. And it was asked by Alex Osborne 5629. The only question I have is, when you are cutting the bar, does it produce fiberglass dust? Borna, maybe you're the best one to answer that question as well.
Absolutely. Just every time you're removing a material, you're creating dust. It doesn't matter if it's a fiberglass, if it's concrete, if it's wood, if it's drywall, you are going to create dust. The question is that dust harmful for your body? The answer to that question has been published by the government of the United States. As I mentioned, fiberglass and resin is not a new material. If that would be a problem, believe me, they would ban the use of fiberglass and resin 80 years ago. So the question is, every time you cut this material, and when you cut this material, the dust coming out of that material is a solid round particle. Solid round particle, and the size is so small, is considered as dust, as a solid round dust. It's no different than cutting the concrete. As long as you have a dust mask to protect the dust to go directly in your body, and it's not harmful. Yes, you gotta cough it out, obviously, but as long as you have a dust mask, you're going to protect all your body and everything inside you. So at the end of the day, that dust coming off of the fiberglass rebar is not harmful. Yes, you need a mask, obviously. So as when you cut the concrete, you need a mask. But the misconception comes from fiberglass insulation. Fiberglass insulation, they do have a different microscopic structure. If you look at a fiberglass insulation, the shape has a little hook shape in it. So when you inhale them, yes, they're gonna go get stuck in your lung. Fiberglass dust coming from rebar is a solid round particle and considered as a solid dust.
Question number 3, is it a one-to-one replacement, or is some other formula involved?
Jeff, this is $1 million question, meaning that in design words, everything is a variable. And everything is based on assumptions. You have 2 engineers with the same projects have 2 different designs, because one is taking one assumptions and the other one is made. You can't say he's right or he's wrong. It's the assumptions that the designers make during design. One would consider this fixed, consider the other one a hinge, the other one consider it, both sides fixed. So at the end of the day, this is $1 million question. My answer to this question, over 95% of cases, it's a 1-to-1 ratio. You do not need to upsize, you do not need to downsize, it's just 1-to-1 ratio. There is 1 or 2% of the jobs that, yes, you can push it down to a lower rebar because, ultimate limit state design governing your design. There are certain designs that is purely governed by serviceability. You have deflections, you have a massive suspended slab with a gas pipe running underneath, and you don't want this gas pipe to deflect by 1/16 of an inch. So then that is a serviceability requirement. And yes, unfortunately, you can't use 1-to-1. You might use 3%, 5% more rebar. It's not the end of the world. You're adding $100 more to the rebar, but you're saving a lot on the, corrosion and all the future maintenance. But for ICF work, because today we're focusing on ICF, in
Right.
ICF words, in a 3,000 or 4,000 square foot home, which you have a foundation wall with the little walls that is protecting the wind load, you're absolutely using 1-to-1 ratio. There is no need to upsize or low size. It's just 1-to-1 ratio reinforcement. So yes, the question to the answer for ICF work, it's a 1-to-1. It depending on the size of, or the design, you have a designer that has designed the steel rebar to its limits. And when you're looking at that design, the steel design, you have too much deflection. So yes, when you go to fiberglass, well, yeah, you can't do it 1-to-1 because the structure with fiberglass will have a slightly higher movement, right? So at the end of the day, but you have another designer that designed the same wall with twice the amount of rebar because his assumptions are different. So when you go there, you're like, oh my God, how come Borna, I can use less rebar in this job, but more on that job? Because these are made with different assumptions. And at the end of the day, you never want your structure to fail. So you can never question any structural engineers or professional engineers' work because everybody is doing their own assumptions and design, and they have to follow the code.
Okay, let's move on to question 4. It's question 4 is actually quite a couple questions all in one again. First part of the question is, are all fiberglass rebar made the same? Second question, and this is maybe the follow-up as to what Rob is looking for, is do they all have the same strength, shearing, and tension? And where can a person go to check out comparison of these things? So Borna, first thing, are all fiberglass rebar made the same?
So Jeff, does all pen and pencils you buy off the market, they're made same? No. Pens are made with the different formulas, with the different pen balls, the quality of the pen balls, the quality of the ink, how durable the ink is. There are so many parameters into making fiberglass rebar. What's the temperature? How do they make it? What's the process? How does the resin, how does the fibers get in there? Unfortunately, not all fiberglass rebars are equal. And in fact, not even the 2 of them are equal. You can't put 2 fiberglass rebar next to each other and say these 2 are the same materials because of the process. So it's going to go back to what Alicia mentioned, that cooking matrix, the cooking formula, where you have to take your formulas, your oven temperatures, your cookers, your polymers, your mixers. So not all fiberglass rebar, and it's primarily because of the process of how you make it. Some manufacturers have a different surface. I mean, you can grab MST Bar, where MST Bar have a totally deformed surface on the bar. If you have seen fiberglass rebar MST Bar, we have a total continuous deformation where this bar can adhere to concrete, and there is no way for you to take this bar out of a concrete if you don't break the concrete. Other products, they tend to adhere to concrete differently, and the bond strength. So this is what I always tell people. You can have the strongest concrete in the world, and you can have the strongest rebar in the world. We can make a concrete today with 9,000, 10,000 PSI, and you can have a rebar that is 250 KSI tensile strength. If these two doesn't bond well, it's absolutely useless. If these two does not transfer the shear forces from concrete to the rebar properly and keep the cracks closed, it's absolutely useless. So going back to answer this question, not two same fiberglass rebars are not made equally. They're totally different than each other. And where you have to find out, you have to go to their brochures, you have to do your due diligence, find out, about the quality control programs, how does these materials made. So you have to do your due diligence to find out that that product is quality product, that product is being, there's a lot of things in there. The second part of the question, I think you mentioned, does all these bars have a similar mechanical performance? Tensile strength, shear strength, tension, shear. Again, unfortunately, no. Each product is different in tension, in shear, in compression. There's a big miscommunication out there. Oh, fiberglass rebar is not good in shear. Well, that's not true. MST bar perform as well as a steel in shear. We have, 250 megapascal, in imperial units, that's, 32, 33 KSI in a direct transfer shear. Steel, your same number, you're about 0.8, 0.7 of the yield strength, which is, 0.7 of 60 KSI. So, you're about 40. So we're very close the value of the shear to steel. In tension, we're 3 times stronger than steel, but not all fiberglass can be that strong. There are products that is only, 1.5 times stronger, some 2 times, some. So unfortunately, not all products are made equally. And for people have to do their due diligence, read about the different product to find out. And one of the most important part in rebar is bond strength. How would they adhere to concrete? Because that is your serviceability requirement on the crack widths. So the higher the bond, the smaller your crack. The smaller your crack, the higher the other values, because your concrete aggregates, your interlock, right? If you keep your crack as close as possible and these concrete aggregates are interlocked, you have a better shear performance, you have better punching shear performance. There's a lot of other things that gonna correlate to that bond strength.
For our next question, we have a special guest that's joining us. Tim Pinter is a longtime ICF installer that is currently working on a large ICF residential project in the mountains of Durango, Colorado. Through his 18 years of experience, Tim has always used steel rebar, but you've recently made the switch to MST bar, including the current mountain project that you're on. Tim, thanks for joining us for this question. Question 5 is, what would a typical insulated concrete form installer experience using MST bar on a job site be in comparison to steel rebar?
Yeah, so I guess I'll contrast a few things for you here. As far as safety goes, particularly on government jobs or Department of Defense jobs, the safety aspect of this is much, much easier to deal with than steel. And dealing with those razor sharp edges from cutting steel is actually what we've seen as our largest percent of injuries is from the cuts from those sharp edges of steel. And then as far as the safety, again, on a lot of these jobs, if you're cutting steel, you have to have fire extinguishers by you at all times, because you're shooting flame every time you're cutting the steel. If you're not using a snapper, if you're using something that's actually some kind of abrasion, it's going to shoot sparks everywhere. The safety aspect of having something that's easy, fast to move around and cut is incredibly important. So, couple of the points that I would throw out there just from the very, very real world angle of things. Obviously moving it around, it's so much lighter. Your manpower goes way down when one guy can grab 10, 20 pieces of product and move them across the site. There are specific weights on different jobs that you have to use 2 men if you've gone over a certain weight. And so now you're doubling your manpower. I'm from Wisconsin, so I'm a northerner. And so a lot of people down south, they don't understand. Cold has challenges. And everybody hates the steel job because no matter what gloves I put on them, their hands are actually freezing off after handling that stuff.
Go the polar opposite.
Oh, yeah.
The people in the South, I've had burn marks here from packing steel rebar on my shoulder. So it's the polar opposite is the exact same problem.
So next point I wanted to make from an installer aspect is you don't need any special tools. We have thousands and thousands of dollars of rebar benders, cutters, every kind of thing that you can have out there. They're heavy, they're expensive, and they break often. Where all I need is a diamond blade on an angle grinder, and we zip through this MST bar. And then also with ICF, depending on what blocks you use, we're certified in many blocks, but a lot of them come with their webs having little saddles and things that you slide your rebar into. And the MST bar being able to have smaller diameter doesn't run into as often as of them not fitting. For example, normal ICF blocks will not even let you take a number 6 bar in it. You have to cut out the saddles to lay that in. So that's a nice perk to the MST bar.
Question number 6. This one is a compilation that came through on a bunch of different comments. So we just kind of compiled it together. Marty, we're going to point this one at you. Question is, what install differences between what we are used to with steel rebar? Also, is the same overlap required? And what about using MST bar for footings in ICF walls?
The best way to do this is it's installed exactly the same as steel. You're going to use in the ICF walls, you're going to put your horizontals in as you go up the wall, and then you're going to drop your verticals in from the top. Anytime you overlap steel or you run steel and you have to overlap lengths, you need an overlap distance. The general rule of thumb is 40 times the diameter of the bar. We maintain the same thing. If we're on a particular project and somebody wants 50, we can do with that. But in general, it's the exact same as steel is what we use. And then as far as the footings, we use them in the footings. It's interesting. One of the things just happened recently for me. We were gonna tie the vertical bars in, the dowels in for the footings. And the homeowner wanted to use L bars. So I talked to Borna months and months ago about just using straight bars because of the bonding strength. And then I went one step farther, and what we end up doing, instead of trying to wet set these all afterwards vertically, I literally pound them in the ground through the middle of my footing because it's not going to affect anything, and left them sticking straight up. And it worked very, very well. So there's so many things that are identical to steel, but there's so many benefits with the quarter of the weight, the handling around the job site, the cutting. And now here I can literally put bar into the dirt below the concrete footing, come up through. I'm not saying that's the best way to do it, but I'm saying it was possible because it's not going to deteriorate. You don't have to worry about the rust, et cetera, et cetera, et cetera.
Yeah, one thing I do have to mention about foundations is because the bar is non-magnetic and it does not transfer any electrical, it cannot be used for grounding. So that is something that builders need to be aware of, is they have to find another way to ground their electrical because they can't ground it with an MST bar. But that's not an issue. You just have to find another way to do it, or just throw in a bar in there for just grounding.
Matt, we're going to keep going on with you here. Question number 7 from Smore45 is, so a long piece of MST is bendable. It just won't stay bent.
Yeah, so they picked that up from the video in which Marty was on site, and he took a 20-foot stick and he bent it back on itself and he let it go and it sprung back to its original state because it wants to stay straight, right? So the reason Marty pointed that out is if you are kerfing your ICF and you are doing a curved wall, it is very difficult to get steel in a curved state because of its weight, because of its nature, whereas this bar is flexible. So if you had a bay window that your ICF had to curve out into because you had a curved window, the MST bar is going to fit right down into those saddles, as Tim mentioned earlier. And that MST bar is going to form to that shape much easier than steel, but it still wants to stay straight. However, it can be bent if you get with MST and you need saddles, you need 90s for your corners, you need your C's for your lintels that you're going to put in over top of, or S's. There's several different shapes that people use in today's world. You can get it in a fixed shape from MST bar directly.
Okay, question 8. What is the cost of using MST bar compared to steel rebar? The issue with this is that steel rebar fluctuates in price and it fluctuates in just in general, but then also there's a regional factor to it as well. So it's a bit challenging to exactly say, okay, what is the cost? But Matt, nevertheless, love to hear your perspective from a contractor to hear what was your experience very recently.
Yeah, so I can't really speak to foot price or 20-foot stick price because I'm in Southern Indiana and someone out in Idaho or Colorado or Wisconsin may have a totally different foot price. Okay. What I can say is I quoted the ICF pool, let's just say 6 months ago. Okay. We recently got bar in 2 months ago, and I confirmed my steel pricing prior to, and I also confirmed my steel pricing as of the 14th of this month. What I can speak to is in my applications, per the designs that I was given by Alicia and Marty for these specific applications, is the steel bar was roughly 20% more in cost. And that's after I increased the amount of bar that went into the wall based off of Alicia's recommendations for the water retention. It was still 20% more, and I used more MST bar than was recommended. The other thing that I would like to point out is 6 months ago when I provided this quote compared to November 14th, whenever I got today's pricing, if you will, on steel half-inch bar, it was 7% less 6 months ago when I performed the quote compared to 6 months later when I would have purchased the product. Mm-hmm. That's a short time frame.
Yeah. Yeah, that's good.
And let me state one more thing real quick. MST bar was the exact same price when I quoted it as to when I purchased it. And that is facts. That's what that is.
Marty, you're not only the technical advisor for G2 and for MST bar, but you've been involved in many builds as well. What's your experience?
When you actually look at it, in most cases, the number 10 number, the 10M number 3 bar in the ICF world tends to be very close on price, maybe a little bit less in some areas. It's almost a 1-to-1 par in most cases.
Question 9, and it's asked by Steve Push. What will fire do to the rebar? Is it toxic due to high heat?
We are dealing with a system. People don't confuse a material and a system. We are selling reinforced concrete. We're not selling rebar. This rebar is meant to go inside a concrete. So at the end of the day, it's a reinforced concrete. The concrete itself is one of the best insulation materials for fire known in the human history. So technically, the concrete itself with the enough cover concrete, which according to ACI, according to CSA, depending on where you are in the world and which code you use, you have a minimum cover concrete, which is about 1.5 inches or 40 millimeter. That minimum cover concrete provide enough protection to your rebar for the heat or fire to never get your rebar to the burning point.
And like Borna said, the tensile capacity, you have to get the bar over 350 degrees hot. It can't burn because there's no oxygen in the concrete to actually burn the bar. So you have to have oxygen there to feed the fire. So toxicity doesn't really come into play. The toxic's going to be whatever's in that you're burning off in the concrete mix. So whatever additives you have are going to be the toxic part of it.
Question 10. Let's keep moving on. And this one is again more probably for Borna and Alicia, but how does MST bar differ from steel rebar in regard to how the concrete reacts and bonds with the actual bar? Also, what is the difference in the tensile shear strength of MST bar compared to steel?
The best way, I always tell people that rebar and steel rebar and MST, I always compare it to a paper clip and a rubber band.
Okay.
So a paper clip, you can only do so much before you break your paper clip. So you can bend it and manipulate, and then it snaps and it's no good. So MST is more like a rubber band. It will stretch and pop back until what we call is creep. And you've kind of stretched it out to the point where it's not usable. But that rubber band gets a lot more use than that paper clip ever does. Shear, it's about equivalent. So I think about when I'm doing ties and hoops and things like that, it's usually a 1-to-1 because they're almost identical. Dowels, same. I don't have an issue doing a 1-to-1 for dowels. So those are the two big things, but the performance when you put it in the concrete is the biggest bang for your buck.
Next question is really more just an attribute of MST. It may not really affect an ICF build, but it's probably worth just talking about because it does speak to some of the properties of the bar. What about using MST bar in seawater? Seems like it would be a better fit to use fiberglass rebar. Does salt have any bad effects?
So MST bar is taking over the Florida coastline. So we have building departments that are requiring MST bar in their seawalls because it does so well. And there's been ACI, there's some research documents on the website that you can go and look at, is using salt water actually makes a stronger concrete. So when you're using a stronger concrete and you're putting a bar that can actually take salt without corroding, no alkalides. So the big thing that I always tell concrete guys is you don't need potable water. So because you don't have the issues of a reaction corroding the bar while it's in the concrete. So you go for and just use whatever water you need that makes a strong concrete. Don't worry about it being potable. But there's research out there that I think with time, you're going to start seeing people use salt water because you're getting a better concrete. And you have a reinforcement now that can strengthen that concrete and tension and get an even better product.
There's a small disclaimer that I need to make, and Alicia is 100% right. And the disclaimer is very simple. It's the concrete that they're using should be alkaline resistant concrete. There are different grades of concrete, and concrete have sand and aggregate in them. So all the contractor have to verify to make sure that cement bag they're buying has an alkaline resistant aggregate, because you don't want the aggregate itself to react with the salt. That's the only thing. If you are certain that you're using what they call the secrete is the formula for the type of a cement that has an alkaline resistant aggregate, then you can just go grab water from the ocean, put MST bar, and you're done.
Marty, you're our final comment answerer here. And this is question 12. So this is the last of the bonus questions, but it's an important one. And the question is, how do we know what size MST bar and spacing of MST bar to use in my ICF build?
In the ICF world, there are charts. Many different manufacturers have provided charts for each of their own products. I am in connection with the ICFMA, where they are talking about a whole new set of charts in 2024, which they're working on right now, that are going to be amalgamated into one type of chart to minimize all the confusion going back and forth, whether it's an 8-inch spacing on webs or 10-inch spacing on webs. So with charts available with restrictions for certain builds up to certain size, certain height walls, it's literally we're a 1-to-1 in 99% of the cases right now. And then once we get outside of those charts, by all means, get a hold of us. We'll get the engineers involved. Borna has a great team. They back us up on getting us information on specific job site situations, and then we carry on from there and do what has to be done. The biggest thing is going to be the ICF world is used to having these charts. We're mimicking them now to make sure that we're in line with the new charts, to make sure things are going to flow easy, so that most contractors carry on as they did in the rest, like in the days gone past. It's taken 20 years to get up to that point where these people feel comfortable using those charts, where the building committees or building departments use these charts, et cetera, et cetera, et cetera. It's all about communication to make sure your site-specific project is dealt with properly.
I think that was a great wrap up, Marty, to kind of bring us to the end of this Q&A session. I think, again, it's critical to remind everyone that's watching that today's conversation is specifically related to MST Bar brand of grade 3 structural rebar. And that can't be emphasized enough, especially in all the drawings that Alicia has done. It's very specific to the properties and the product of MST. For more information, if you are interested in MST Bar for your next ICF project, like Matt said, please reach out to G2 Building Products. G2 is the source for MST Bar that serves the ICF industry with technical expertise, engineering expertise, and you can access MST Bar across United States and Canada through G2 Building Products. Feel free to reach out to us online at g2buildingproducts.com or our toll-free number, which is 1-800-731-5098. Once again, everybody, thank you so much. Borna, Alicia, Marty, Matt, this has been fantastic. And for Tim for joining us as well. You clearly are the experts on these topics, and I think we went above and beyond on answering the questions with relevant and very detailed answers that are going to get anybody that's involved in ICF and rebar and concrete well on their way. So thank you so much for joining us. This has been great. I hope you've enjoyed yourself as well.